Hello and welcome to the Canopy Simulations platform. What I'm going to do is go through a demo aeroscan for Barcelona at qualifying weight to show you some of the features of our simulations platform. So we sign in and here's the home screen. On the left we have sets of simulation inputs, so cars, tracks, weather and explorations. On the right we have studies that we've already completed and the status of our computing. So for our aeroscan, first off we're going to need a car, and we have the Barcelona baseline here. Trouble is, this is the race baseline, so it's got 50 kilos of fuel on board. So we'll edit this and change chassis MCAR down to qualifying weight, and then we can click stage. Now this brings up the staging area with our car in it, and this is a sort of race bay where we store one of each ingredient for a study before we're ready to commit that study. So the next ingredient is a track, Barcelona. That's the racing line for Barcelona, so we stage that. Weather, 20 degrees and dry, that sounds nice. Exploration, now we're going to define a new exploration. This is where we tell the platform what parameters we want to sweep and through what ranges. For our aeroscan, we're going to choose a star design type because we're just doing a single sweep in a single direction. We're going to do 20 simulations along our sweep, and here we define the parameter we want to change, the way we want it to be added to the baseline car, the start value and the end value, and how it will change between the start value and the end value, i.e. linear or logarithmic. So it's an aeroscan, so we're going to change lift and drag at the same time and see what the best trade-off is. So let's put the lift parameter in here. We're going to have an additive type, and we're going to start at minus 30 points and end at plus 30 points of lift. Then we add another subsweep for drag. These two subsweeps will be done in parallel. So this parameter is also going to be additive, and we're going to start at minus 8 points of drag and end at plus 30 points. So what this study is going to do is start at minus 30 points of lift and minus 8 points of drag, and finish at 30 points of lift and plus 30 points of drag, with 20 stops along the way. So we've given it a name, Simple Aeroscan, and we click Create. And we can see it now in our list of possible explorations, so we'll stage that one. And now you can see we have one of every ingredient for our study. So we choose a simulation type. We're going to choose quasi-static lap, as we'd like to know the lap time at each point, and we give it a name. And then we click Commit. And the platform now is dividing up that study, combining the exploration definition with the baseline car, and sending 20 different lap simulations off to be done, computed in the cloud. It's worth mentioning at this point that the atomic unit of exploring your car's behaviour in the Canopy platform is the study rather than the traditional single lap. Of course, it is possible to do a single lap in the Canopy platform, but we would consider that as a sort of degenerate sweep rather than a sweep itself being a special occasion. So as we can see, those jobs have already completed before we even got to the page, in 23 seconds for 20 laps. So let's have a look at the results. So we've got a recap here of how many jobs were done and then all of the ingredients that went into the study, so that you've got full traceability and you can find out what car was used and what track was used, etc. And then here we have the results. What we're looking at here is our 20 points from beginning here to end here, varying along the x-axis. Here it's showing lift. If we click on this, we can get it to show drag instead. You can see that the values change. And we can see that at this end, we don't have enough downforce to go through the high-speed corners fast, so we're slow. At this end, we have too much drag, and we're slower again. And in this region, we're optimal. And this is what we wanted to know from our aeroscan, and this is what we wouldn't have found out by doing any sort of 2 or 3 of these laps. Being able to do 20 really gives you a good picture of how your lap time changes as your sweep goes from one set of values to another. But of course, we don't just want to see the overall lap time, we'd like to see where each car gains and loses lap time relative to one another. So if we go up here and select View Jobs, let's compare, say, Job 5 and Job 15, which are about equal lap time, but with very different ways of achieving that lap time. So this has brought up the sort of staging area for visualization. So if we click on lap as a kind of comparison we'd like, we get the telemetry viewer. And here we can see the usual channels: throttle, brake, steer wheel, V-car, G-lat, G-long, G-vert, tyre slips and aerodynamic coefficients. We can see the difference between the two cars in the aero coefficients for a start. And we can obviously also see it in the end of straight speeds where the drag makes the difference, and in the high speed corners where the downforce really makes a difference. You can see here that's a difference of over 1.5 meters per second for the high downforce car, and here it's the other way around and it's about 4 meters per second. I mean, if we go and have a look at turns 9 and 10, which is the higher speed corner and the lower speed corner consecutively, we can really see that one car is fast in a way that the other car isn't, and vice versa. If we change to T-lap on the x-axis, we can see that although this faster, lower drag car gets to the braking point much sooner, actually its lack of speed through mid-corner and late entry means that on the way out of the corner, it's pretty much already caught up with the lower drag car. And we can see this pattern repeating through the high-speed final corner. So that concludes our demo of the Canopy Simulations platform. If you have any questions, please don't hesitate to email hello@canopysimulations.com.